Hi guys, I am Bailey with MyMathExperts, and today I'm going to teach you how to solve the following problem. The length of a rectangular swimming pool is 20 feet greater than the width. The surface area of the pool is 1,500 square feet. What are the length and width of the pool? Okay, so first for problems like this, I always like drawing a picture just to kind of help figure out what we've got going on. So first, we're going to need to establish a variable. So I'm going to say, let's let W equal width, just so that we have a place to start labeling our diagram. So we have length and we have width for a rectangle. So let's say that this side is width. That means this side is also width. And then it tells us the length is 20 feet greater than the width. So these are going to be width plus 20s for our lengths. We can even say length equals width plus 20. I do my L's like that just so they don't look like ones. They also tell us that the area is 1,500 square feet. So 1,500 square feet is the area. I don't know why they say surface area there. That's typically reserved for three-dimensional shapes, but that's okay. Okay, so let's think about the information we have. We have something representing width, we have something representing length, and we have something representing area. Probably a good idea to get an area formula on the board for this rectangle. So the area of a rectangle is equal to the length times the width. And then let's get this all in terms of the same variable. Because we have length in terms of W, so we could say our area is equivalently equal to W plus 20 times W. And we actually know what that area is. It's 1,500. So 1,500 equals, let's just distribute that W here while we're at it, W squared plus 20W. Okay, so now it looks like we have a quadratic equation on our hands with only one variable. So that means we can solve it because it's only one variable now. If we had W and L both in here, we would need more information. We would need to come up with a second equation so we have a system of equations. But since we have just W's, we can solve this. And since this is quadratic, that means we're going to have to turn to our quadratic equation solving tool set. First of which indicates that we want to get everything on one side here. So I'm going to go ahead and subtract the 1,500 from both sides. All right, cool. So now we have a couple different options. We could try to factor W squared plus 20W minus 1,500. However, I don't know all the factors of 1,500 off the top of my head. So what I'm going to do instead is use the quadratic formula. Usually at this point, you would bust a calculator out to kind of help you do some of these calculations. I'm going to do as much as I can without a calculator, because if you try to put this whole thing into the calculator, you could run into some errors. Just user error happens to all of us. So I recommend trying to solve this as much as possible, simplify this as much as possible without going to the calculator. But let's get the quadratic formula up on the board first before we even think about doing any of that. So this is going to be W equals negative B plus or minus B squared minus 4AC over 2A. So our B here is 20. So this is going to be negative 20 plus or minus square root of 20 squared. That's 400 minus 4 times A, which is 1, times C, which is negative 1,500. Over 2A. A is 1. Let's keep going here. Negative 4 times negative 1,500 is positive 6,000. So 6,400 at the end of the day in here. Over 2. Let me scoot us around a little bit here. And then square root of 6,400, I think, is 80. Again, you can go to the calculator for this stuff if you're not sure. Over 2. Cool, let's go ahead and just divide both of these by 2, actually, while we're at it. So that's going to be negative 10 plus or minus 40. And now we have our two solutions So our two solutions are going to be negative 10 plus 40 and negative 10 minus 40. So negative 10 plus 40 is 30. Negative 10 minus 40 is negative 50. And this is where you have to start thinking about, okay, one of these makes sense and one of these doesn't make sense. Negative 50 doesn't really make sense as the width of a pool because we can't have like a negative pool. So I think 30 is the reasonable answer here. Usually when you work this out in the quadratic formula, you're going to have one reasonable answer and one not reasonable answer. If you have two reasonable answers, you just put them both as answers. But for now, it looks like our width is 30. And then, so width is 30. And then to find our length, you would just put that back in here. They told us that the length is 20 feet greater than the width. So our length would be 30 plus 20, which would be 50. And let's see if one of their answers, yep, B is that answer. So I'll get everything on the screen here so you can look at it all if you want. But this is how you would solve a problem like this. Thanks for listening. Have a great day.